Hi everyone, welcome to Iconic Chemistry classes. In this video, I am going to discuss elimination reaction. What is elimination reaction? Unsaturated compound convert into saturated compound and something is eliminated from substrate. Common eliminated products HX, H2O, X2 like that. So reactivity order towards E1 and E2. E1 elimination, E2 elimination, reactivity order same. 3 degree greater than 2 degree greater than 1 degree. When it comes to alkyl halides, same order. When it comes to alcohols, also same order. Clear na? Yeah. Sometimes in examination they may ask like this: which alcohol easily dehydrated? 3 degree alcohol. Which alkyl halide easily undergoes E1 reaction or E2 reaction? 3 degree halide. Clear? Yeah. So what is E1 reaction? E1 it's like SN1. E1 reaction two-step mechanism. Carbocation is formed as intermediate. Next, reactivity directly proportional to stability of carbocation. Weak base is required like water, methanol, ethanol. Generally, students, E1 reaction means we have to use weak bases. Water, methanol, ethanol. These are very, very prominent weak bases to do E1 reaction. Next, temperature is very, very important. Greater than 50 degrees Celsius, which means little bit high temperature. Solvent, PPS, which means polar protic solvent. So just have a look. This is a 3 degree bromide. 3 degree bromide react with water at a high temperature to form alkene. Clear na? Yeah, this is E1 reaction. Next, one more example. CH3CH2Cl react with water 15 degrees Celsius. Here 70 degrees Celsius. Yeah. Actually, the difference between E1 and SN1 only temperature. Greater than 50 degrees Celsius means E1 reaction. Below 50 degrees Celsius means SN1 reaction. Clear na? Yeah. Generally, SN1 means room temperature like that. So CH3CH2Cl H2O 15 degrees Celsius. Yeah. Below 50 degree means SN1. Above 50 means E1. Clear na? Only temperature is the difference. Remaining same to same. Yeah. Next. CH3CH2Br react with methanol 20 degrees Celsius. You tell me, is it E1 or SN1? 20 degrees Celsius means SN1. That's the reason you will get a substituted product, not alkene. You will get ether here. Clear? Yeah. Next, E2 reaction. E2 it's like SN2. One-step mechanism. Transition state is formed. Reactivity directly proportional to stability of transition state. Next, E2 reaction key points. Very, very important key points. First point, basicity order. R minus greater than NH2 minus greater than RO minus greater than OH minus. Clear na? Yeah. Actually, right to left basicity increases in periodic table. R minus is nothing but it's like CH3 minus. Clear? Yeah. These are strong bases. Most common reagent is alcoholic KOH. Alcohol plus KOH. You will get like this. Clear na? Yeah. Next, second point, anti-periplanar mechanism takes place. This is very, very important. Anti-periplanar is nothing but if a halogen removed from top side, then hydrogen should be removed from opposite side. Okay, na? Anti means opposite. Simple logic like this. You will get alkane. Here Br is a thick line or solid line. Next, this is a dash line. Both are opposite. Na? Both are opposite means reaction possible. If both are same means reaction not possible. That is the meaning of anti-periplanar mechanism. Okay, na? So E2 रिएक्शन होना बोले तो कंपलसरी ऐसा अपोजिट होना स्टूडेंट्स, नहीं तो रिएक्शन नहीं होते. की पॉइंट जरा देखो अच्छा से, इधर देखो. To reaction occurs, both hydrogen and Br should be in opposite direction, which means one should be in away from the viewer, another should be in towards the viewer. This is the meaning of towards the viewer. This is the meaning of away from the viewer. Then reaction possible. Here both are towards the viewer. Reaction not possible. Clear? Yeah. And rate directly proportional to alkyl halide and base. So this is E2 reaction. That's the reason it depends upon two things. Clear na? Yeah. One example. CH2H, CH2X. Anti-periplanar mechanism. You will get a transition state. This is the rate of reactivity, 3 degree greater than 2 degree greater than 1 degree. When it comes to alkyl halides, iodide greater than, bromide greater than, chloride greater than fluoride. Clear? Next, fourth point. According to Sedgwick rule or Jetsov rule, more substituted alkene is major product. Everybody knows this one. Clear? Here two possibilities. Actually, here you will get two products. One is 1 butene, second one is 2 butene. Out of two, which is major? 2 butene is major. But here one important point is that if you take small base like sodium or potassium methoxide or methoxide, you will get like this. But if you take bulky base, large base, Hoffman product is the major. Yeah, this is major here. These 2 points very, very important. With the small base, Sedgwick product is major. With bulky base, Hoffman product is major. Clear? Yeah. Next. E2 reactions are stereospecific, regioselective and stereoselective. So what is the meaning of stereospecific? Stereospecific is nothing but it is related to reactant. Suppose this reactant and this reactant, two reactants. But out of two, which one gives reaction? This one gives reaction. This one does not give reaction. Okay, na? Yeah, stereospecific means out of two, specifically which one gives reaction? This one gives reaction. That is the meaning. Next, regioselective means this concept is related to product. Suppose if you get two products, 1 butene and 2 butene, which is major? 2 butene. Yeah. Next, stereoselective means here 2 butene is major, but 2 butene shows geometrical isomerism, cis-trans. Out of two, which is major? Trans major. Yeah. That is related to stereoselective. Clear na? Yeah. Next, examples. Which is more reactive towards E2 reaction? This is a 2 degree halide, this is 1 degree halide. So which is more reactive? 2 degree. Next, this is alkyl cycloalkyl bromide. This is cycloalkyl chloride. So which is more reactive? Bromide. Next, this is a 3 degree halide. This is a 2 degree halide. So 3 degree is more reactive. Next, this is allyl. This is secondary. So which is major? Actually here this is major. Why? Because you will get a stable product. So reactivity depends upon stability of product. That is also beauty. Clear na? Yeah. So due to conjugation. Conjugation means resonance. So this is more stable. Because of that reason this is more reactive. Clear? Next. Here Br towards the viewer. Hydrogen away from the viewer. Reaction possible or not possible? Possible. Here both are hydrogen and Br both are towards the viewer. Not possible. So what I told you, anti-periplanar mechanism takes place. Anti-periplanar mechanism means one should be towards the viewer, another should be away from the viewer. Then only reaction possible. But here both are towards the viewer only. Clear na? Yeah. Next. So this one and this one, which is more reactive. So reactivity depends upon stability of product. So here you will get conjugated product. That's the reason this is major, which means this is more reactive. Next, same logic as usual. Here two possibilities. Between this alpha beta you will get a double bond. Between this alpha beta you will get a double bond. So this is one product, this is another product. But if you go with alpha hydrogens, here only one alpha hydrogen, but here 8 alpha hydrogens. Still this is major. Reason, this double bond conjugated with Benzyl ring. Because of that reason, here I wrote which is a major product out of two. This is major product. Clear? Yeah. This is a 3 degree bromide. If you take small base, this is the major. Small base means Sedgwick product is major. Sedgwick product means more substituted alkene. More substituted alkene means more alpha hydrogens. Clear? So this is the Sedgwick product. Sedgwick's. And this one is Hoffman. Clear? This is actually dehalogenation, not dehydrohalogenation. If they give zinc heating or sodium iodide acetone heating, you have to do dehalogenation. This is also elimination reaction. Why? Because this is saturated, this is unsaturated. Next, very important point, 9th point. So when poor living group बोले तो fluorinocyanide. अगर poor living present है तो CB reaction takes place. Conjugate base, unimolecular elimination conjugate base reaction. Clear na? Yeah. Which leaving group here? F is nothing but 4Lg, 4 leaving group. Then which mechanism takes place? Even CB. Clear? Even CB means you will get intermediate carboanion. Finally, you will get alkene only. Just have a look, you can understand. Next to 10th point, quaternary ammonium salt. Quaternary ammonium salt on strong heating, you will get alkene as well as 3 degree amine. Clear? Na? Yeah. So according to this concept, Hoffman product is major. Clear? Na? Actually, here you will get two possibilities. Here you will get a double bond. Here you will get a double bond. Clear? Actually, this is alpha. This is beta. This is alpha. This is beta. This is this side one possibility. This side one possibility. But this is major.